if you actually do all of this, you will actually become a genius. It's very counterintuitive, obviously, to the way our culture of learning and the education system, and it's part of the indoctrination. So my problem with the A-level textbooks is that, so in, say, this book, I don't know if all like of these old textbooks are like that. So the knowledge is more not really knowledge, it's more just memory, and then once you forget that memory, then you forget the knowledge. Okay, so the way to actually become a genius, especially a maths genius, is the complete opposite way that school systems are set up. So in this video, I'm going to talk about all the evidence from cognitive science and also examples from actual geniuses and how they became geniuses. So let's talk about it. One of the main reasons why people struggle a lot with maths is because of the way it's taught, because of the way the school systems are set up, and also just the culture around learning in general. So the culture around learning, what has been developed, is indoctrination. So back in the days when public school systems were being set up, the idea was basically surrounding indoctrination and trying to build a society of citizens. Could even say obedient citizens. But you guys probably already know this. So in today's video, we're going to talk about everything that you actually need to know to actually be able to learn. And I've watched a lot of these videos, and some of the things I'm going to talk about are things that haven't been brought up at all in any other video. So let's go. Oh yeah, and for context, I guess I basically taught I teach myself maths and physics. I did my master's in computational neuroscience, and I taught myself maths and also taught myself to code before my master's, and yeah, basically taught myself like basic graduate level linear algebra and calculus, and yeah. So the thing that I'm actually not going to talk about in this video is basically productivity and stuff like that, because that part actually took me a while. Like it literally took me probably like 2 years to fully become disciplined and actually become productive. So that is a whole other story on like kind of more to do with, I guess, training your nervous system and kind of changing your mindset. But yeah, today we're talking about actual techniques for learning. Okay, so let's reenact a day of learning and go through the steps of what you do. So you wake up in the morning, what is the first thing you do? Obviously, this is like not even step 1, this is more like step 0. So you want to plan, you want to know what you're doing. I think that's the part that we basically already know. So yeah, I guess the only thing I'll say about this step and having a plan is that I know a lot of people use like online courses and stuff like Khan Academy. I think those types of courses have a purpose, and obviously if you don't have a lot of time, then those courses are good. But if you really want to deeply master maths, like if you want to become a master at mathematics, then obviously the online courses are obviously not going to be the way to go. Obviously the best way is the books, but also they're literally undergraduate and graduate courses online set up how they would be set up for students. So what I always use is MIT, because it's just like the best, honestly. It's like the best resources to kind of structure your learning, honestly. Oh yeah, this is something I didn't actually know at the time. So at the time I studied calculus on MIT, but I didn't know they had 2 calculus courses. So they have calculus normal and then they have calculus with theory. So if your goal is to do more of like a pure maths education, or then study in depth, then obviously the calculus with theory would be the best. By the way guys, this video was getting really long, so I had to cut out the part where I was kind of walking through how to find resources and stuff like that. But leave a comment if you actually want a video on how to actually find really high quality resources. Also, I'm gonna post like a whole bunch of videos on how I organize my Notion page, so subscribe so you can get notified on when that comes out. It's gonna come out in a few weeks. Okay, so got that out of the way, plan, whatever, you have your plan. Okay, cool. Starting the day. So let's say this isn't the first day that we're studying, say it's the second day or whatever, and we studied something before. So the first thing you want to do for your study session is cold active recall. So that basically is recalling information that you studied before. So you can either just think about it, you can write it down, and with maths obviously you can do questions, like questions from before. And the cognitive science phrase for it is interleaving, and that's basically just answering different types of questions. So yeah, I've mentioned all the things that you've probably already heard. So these are the things that you probably haven't heard. So I guess it's two things that I have to mention. So the first thing is something that you probably have already heard as well, but might not have heard in this context. So when it comes to cold active retrieval, a really good way to kind of do that and to build the connections in your brain is to build a mind map from scratch. So mind maps are really good just for like your notes in general, but then also creating mind maps from scratch and kind of putting the knowledge together from scratch is another way to kind of build those connections in your brain. And then also the one that you probably haven't heard of is creating a problem to solve. So I think this is literally the step that will take you to that genius level, because instead of like taking questions from a book, you're literally thinking about creating a problem based on your knowledge. I feel like I do this all the time with trigonometry. So if you start reading this book, it's Euclid's Elements. If you start reading this book, you'll start to think about this a lot. I read one of them. So it says, out of 3 lines which are equal to 3 given straight lines, to construct a triangle, thus, it is necessary that 2 of the straight lines taken together in any manner should be greater than the remaining one. Like, it's stuff like that. I think about stuff like that all the time, and I'm just like, okay, what if I had a circle and then I had a line? What would be this triangle? Or like, what angle would be bigger? It doesn't even take that much effort, because sometimes you could literally just be walking, you could just be chilling and just think about like different maths problems. This part maybe you'd want to spend not as much time, but it depends on how much time you want. And also you could basically plan to have a whole day of this, so a whole day of cold active recall, which would be definitely very beneficial to like have a schedule one day each week for stuff like that. So creating problems out of thin air, and also just like writing down and making mind maps of all the knowledge that you have and how everything connects, that's going to take you to genius level already. And like, we haven't even really started the study session. So yeah, okay. And now the next stage, I know for a fact that people don't do this, and it's not what is encouraged, and it's part of the indoctrination. So this method, I think, is what makes learning maths so fun, like genuinely so enjoyable. So it is basically solving problems without ever knowing the theory or without ever reading anything. Also, this also applies to A-level students, because if you're watching this and you do want to actually get to that next level, and obviously you want to start studying the things that you're going to learn in class before you actually learn it in class. So I feel like the class session should be more of like a review, and where you want to ask questions. You don't want to learn that topic for the first time in class. So basically, yeah, I think the A-level book is the easiest example to give for this, because the way that it's structured going to make it simpler to explain what I'm talking about. So okay, let's say we're opening the A-level book, we're on a new subject. This subject is boring. Do you know what, I'm actually going to do this live with you guys and actually try to solve something. So let's go on to the hardest thing. No, let's do something to do with trigonometry, because I feel like I don't know, I think I'm good with trigonometry, I think. But okay, this is one that I was curious about. So it's called the T formula, and I've never heard of it in my life, I don't think. But okay, so let's say we're on a new topic. So we have all this information that they're trying to tell us, the theorems and the equations and everything. And that's normally what happens in school. Like, they always tell you this equals this, like trigonometry, sine equals whatever. But what the best way to learn and the best way to get to that next level, like the genius level, like the master of maths level, is to try to figure out the theorems and the problems before ever even seeing anything. So what do I mean? So okay, cool. So the way this is laid out is really simple. So the first thing you want to do is go to the example. You don't want to even look at the answer. You don't want to read anything. Just go to the example straight away. So now here we have this example. So it says, given that tan theta over 2 equals 3 over 4, find the exact values of sine theta. So the only context I have, obviously, if it's something really new, you want to have a bit of context, so you know what the chapter is called. So it's called the T formula. So I'm guessing there's some type of formula that you can use to answer this, right? So you want to start thinking, what is the formula? What even, like, if I was trying to come up with a formula to solve this, what do you think I would do? Like, where would I even start? And that's what you want to start thinking. So I guess here, okay, let's say tan theta over 2. So that means, I mean, I feel like the way I would do it is just get a second variable, like let's just say gamma, I don't know, and say gamma equals theta over 2. So tan gamma equals what? I guess that's where I would start. But I feel like it's probably too simplified, especially because this is like literally the hardest part of the whole A level. So I mean, if there was a formula, okay, I'm just thinking of loads of different things right now. So this probably is not gonna be relevant, but I mean, technically tangent equals 1 plus cosine, or 1 plus cosine, no, cosine squared plus sine squared equals 1. Tangent equals, is it cosine over sine? Yeah, but basically that's kind of the type of things you want to do, and you want to start thinking like what would be relevant and what would be not relevant, and you just want to start thinking about, just throw everything you have at it and just start thinking, basically. And yeah, this is why this method is actually it's going to take you to the next level, because I can't remember if it was the same day or the next day, I've realized, like, I wasn't really thinking properly in this video. I think I was just thinking about getting the video done, because I think it's actually so simple. Like, literally, what I said at first is to get a second variable, say gamma, and then say tan gamma equals 3 over 4, and then solve for gamma. And then theta would just be gamma multiplied by 2. And then then you have theta, and then just plug in sine theta and cosine theta. I'm pretty sure that's literally what they're asking. So I'm guessing that specific example is just the beginning, and it's going to lead up into solving the formula. So at this stage, I would still want to think about what this formula could potentially be. Maybe there's a pattern in when you divide angles, and maybe there's some type of pattern. So yeah, and then I would continue going through the examples, trying to figure it out for myself. And I would hope that I would finally understand derive or come up with a formula for myself without ever even having read the book, without ever even being told the answer. That's basically where you want to be. So if you find yourself like correcting yourself, or you find yourself like telling yourself, like maybe after a while of thinking about something, or even after moving on, and then you think to yourself, oh wait, it's actually that. That's basically how your brain is, like, that's basically how you're becoming more intelligent or learning more. Or it's like the structure of your brain is literally encoding the knowledge rather than it being just a memory. And that's what you really want. You really want to be able to figure things out for yourself. And I think you could even call this metacognition. So where you're literally thinking about your own thinking and trying to correct your own thinking. That is the highest form of intelligence. So yeah, the A-level book is really organized, structured. These types of books are, to be honest, I feel like you just have to know how the book is organized, because this book is organized, but it's just so the examples are technically not like a example in that way. It's more of like an example theorem, or an example of the theorem, but it's not like a question, like a problem. So in, say, this book, I don't know if all like of these old textbooks are like that, but this one you'd have to go to, the actual questions are at the end of the section. So it depends how the book is laid out. You want like an actual question so that you can think about how to answer the question. So yeah, basically you could even end up solving a formula or discovering some type of formula without ever even coming across it, which obviously if that happens, then that is a really big deal. That means that you're literally on that level. But even if you don't, it's like the act of trying to apply your knowledge is literally how you learn. So the way they teach in school is that they give you all the formulas and they tell you to use the formula to solve these things. But yeah, even like this guy, probably one of the greatest mathematicians of all time, like he was on a level of maths where he was solving things that people didn't even understand how a human being could solve. He literally told people that a goddess came to him in his dreams and told him the answers, and I think people probably believed him, because it's like the things he was coming up with, there was no logical explanation. Like it was almost like he just pulled it out of thin air, and he was right every time. And this is like high level stuff, and he never went to school. Like he was literally a poor kid from India, and then he became a young man, and he literally got hired by Cambridge, or hired, like they brought him to Cambridge to do, I don't know if he did a PhD or if he did an undergraduate, but he got some type of degree from Cambridge, because the things he was coming up with, it's like the way his brain, yeah. But the thing is, he probably definitely had something special about him. Like he definitely had a gift, but also the way that he learned, I think, also contributed to how good he was with maths. So the way he learned was from this book called, I'm going to put it on the screen, but this book, obviously he grew up poor, so he didn't have access to like loads of books. So the only book he had access to was this book that all it is just like results. So he literally spent his whole childhood having to discover the theorems and the reasons behind all these mathematical results. And yeah, I think that really contributed to how good at maths he became, because he literally had to solve things for himself. And he literally didn't have a teacher or anything. So that, I think, is one of the best ways to learn maths, is to literally try to solve things for yourself. And even if you can't figure it out, because obviously you're learning something new, and also you don't want to spend forever on this, but yeah, even if you don't figure it out, just the act of thinking about what is relevant, what isn't relevant, and how you would personally solve it is gonna literally take you to that next level. And then two things. One is, obviously you don't want to spend too long on it, and you don't want to, like, you want to be careful about thinking you're right, because you don't want to learn something wrong. Like you don't want to think that you're right and then your brain develops the connection thinking that's the connection, and it's not actually the connection. Then it's going to be hard for you to unlearn it. So yeah, basically kind of just approach it as like more of an exploration that you're gonna find out after. And then second thing is so obviously there's limited time, especially if you're in school. So I think personally the best thing you can do is literally read ahead, like way ahead, and start, like, become familiar with all of these like theorems and all of these kind of, not even the actual theorem, but become familiar with the results and the problems. And so for example, say if, okay, right now I'm on, I don't know, what am I actually on right now? So okay, let's say right now I'm just learning the basics. I'm an A-level student, and so what I would do is go to like literally a graduate, like postgraduate level course book, and just look through the problems, read the problems, so you know what type of problems exist. And then the many years that you're learning, you're always thinking about that problem that's going to come up in a few years, and you're thinking, every time you learn something new, you're thinking, like, is this what I would use to solve that problem, or is it this, or is it that? And every time you learn something new, you're always thinking about that advanced problem. And so by the time you get there, you could probably figure it out yourself, and that's where you really want to be, basically. So I'm currently doing this with like Euler's identity, which I really want to get this book. It's Euler's, I think it's like Introduction to Mathematical Analysis or something like that. By the time I get there, I probably would have already figured it out myself, hopefully. And if not, I would be very close to figuring it out myself. And that's definitely 100% where you want to be. So yeah. Okay, so now we start reading, but obviously we're doing active reading. So I guess the first thing I'll say is like people sometimes use the Pomodoro technique, but because obviously the whole kind of idea behind this video is kind of independent thinking and how the culture that we've been raised in hasn't been kind of built around independent thinking. So there's little things like the Pomodoro technique that kind of stops you from engaging in independent, just being independent in general, because you're relying on a timer to tell you when to start, when to stop, when to take a break. But realistically, you should know when it's time to take a break. So the best time to take a break from studying is not when you're completely like done. It's not when you're completely like, okay, it's been like an hour and I can't even think anymore and like I'm getting a headache at this point. It's just before that point. So you know, like I feel like you should have that connection with yourself where you know when it's time to take a break, where you're about to get to the limit and then you want to take that break. And then obviously you know how long the break should be. You should know when like because you don't want the break to be a distraction. You want the break to kind of just like energize you. So maybe go for a walk or like, okay, I have this thing. It's like it's not a timer, it's just like sand. And this is basically when I can't bother to get up and go for a walk, I just like use this, because obviously you don't want to go on your phone because that's going to be a big distraction and you're technically not finished studying yet, you're just taking a break. So you want something that is like not going to be too much of a distraction but it's going to give you a break. So yeah, basically I literally just like spin this around and like just watch it, or sometimes I'll just stare out the window. Honestly, that's the best. That I think staring out the window is the best break for your brain. But also you can like get something like this or like a fidget toy or something like that. That's not too stimulating, but it's like gonna give you a break, and then your mind can relax and then you can go back fresh. Oh yeah, and I actually have a few stuff on my desk that I use when I need to just relax my brain and just take a break, but I don't want to be distracted. I actually understand why physicists have stuff like this on their desk, because sometimes when you're studying you can't override yourself, so you need to like take a break, but you don't want to take too much of a break, so you need something that's gonna help you relax but also keep focus. And this stuff is the best because basically, so let's start with this. No, let's actually start with the most interesting one. So this will like, it's so simple. It's literally just a cube. But then when you look at it, you start to think about how crazy physics is. Like, how is this mirroring? But it's like, it's see-through. Like every side is see-through, but it's mirroring. Like, let me show you. I don't know if you can see. It's basically a prism, guys. But like, it's mirroring, but then it's see-through. So how does it become a mirror? It's something to do with light and kind of like, I guess it's is it diffraction? No. It's either diffraction or it's not reflect. It is refraction. I can't remember the word for it, but basically it's when, I think it's because this is like solid glass. It's heavy, so I'm guessing this is solid glass. So like when the light goes through, it slows down and then it reflects. Then it reflects all the light and then it becomes basically a mirror. Something like that. That's a simple explanation, to be honest. But this, like, sometimes I just look at it and it's so simple, but it's so, and then this is also simple. It's basically just momentum, I guess, but it does make you think about how energy is transferred, because I think these are magnets. They're not that magnetic, but they are a little bit magnetic. So it's weird that when you it's weird that when you kind of hit it they separate, because they're supposed to be attracted to each other because they're magnets. So that is obviously because of like the energy that's being transferred and the momentum, and then when you like hit it, it now becomes like, I guess the charge changes or something like that. But yeah, it's just very interesting that happens. And yeah, You can literally just do this and then for like 10 minutes, and then you take a break, but you're also renewing and refreshing your mind, I guess. And yeah, stuff like this is so good because you don't want to be scrolling through your phone, because then you're going to end up getting distracted. And then yeah, and so active reading is just like active reading. So you're not just reading passively, you're thinking about like why this is a fact, what are the steps adding up to it. And to be honest, guys, this is where my problem with the A-level textbooks is that they're just, I mean, to be honest, this not, I guess technically if we're talking about being independent and thinking independently, then it's not bad that they don't explain the why behind each kind of like theorem and equation, because then I guess that means that you have to figure it out yourself, which is good. But then obviously you don't know how to check if you're right, so you need to be able to check if you're right. So I would say most of the time with these A-level kind of topics, they are actually undergraduate topics, they're just on a lower level. So you can just go to like an undergraduate textbook. Literally what I do is go on MIT OpenCourseWare and look for the same course of the A-level course. So for example, calculus, you'd go to MIT Calculus. Trigonometry is a bit harder because they don't have undergraduate trigonometry, but yeah, basically just find like a higher level textbook and you'll find the proof. So you're looking for the proof basically, and you want to think about why this result is the case. Also, because obviously before you would have looked through the question or an example and you would have tried to figure it out. So you want to ask yourself why, like what was different about what you thought and the actual fact, and what made you think what you thought, and why was it either right or why was it wrong. And then I don't know how people feel about this, but let me know how you guys feel about mind maps, because I don't know, I feel like some people don't like mind maps, but basically mind maps are really good. Like they're a really good way to learn and to kind of connect the dots. Literally, that's literally what it is. It's just a way to connect the dots. You're really interacting with the information and you're really like applying yourself to the information. I guess I can show you guys one of my mind maps. So I have, mine is, it's actually not, it's just a whole one. It's literally a whole mind map for maths and physics altogether. But yeah, I can show you a section where I kind of like I guess split up the logic or the theories behind the dot product. I think that's kind of the best example. So yeah, and so this is basically your study session done, and now we want to start the questions. So this is the part that is kind of tricky, because the evidence from cognitive science has shown that obviously interleaving is the best way to answer questions. So you don't want to, like, if you know what the question is about, then you know, and then you're not really applying your knowledge as much. So this is a trick that I've kind of figured out. I feel like it applies, okay, it doesn't just apply to the A-level textbooks, but it applies to a textbook that is kind of organized, where you have separate chapters, and after each chapter there's a list of questions, and then at the end of the whole section there's a list of questions related to that whole section. And then also at the end of like a certain amount of chapters, there's a whole section of questions related to multiple different chapters. So if your book, I feel like most maths textbooks would be kind of organized in that way. So yeah, basically the way I approach it is I split it up into kind of two sections. So I split up because you do, I think I do gain a lot of, like, it really does help to just bang out like all those kind of like section level questions. Like that really actually does help. But then also the interleaving also helps, because when you have to actually think about what you need to apply. So yeah, basically at the end of each section I bang out all those section questions. Those are the easiest because it's fresh in your mind and you're just like, yeah. But then what I do is I go to the end of the chapter where everything will be mixed up, and I try to answer the questions no matter how far ahead I am. And then when I do the end chapter questions, I don't look at the answers until I get to the end of the chapter. So does that make sense? So you're basically trying to figure out, based on limited information, but you're learning new things every day. And then by the time you get to the end, you would have been like, oh, okay, I know how to figure that out. And so that helps with kind of splitting up the process. So you still get to do the questions and find the answers, but then at the same time, you're giving yourself time to also think and like apply your knowledge at the same time. So yeah, that's how I do it basically. Process is to have a list of questions that you're going to actually find the answers to then and there, and then also have a list where it's more mixed up and you're giving yourself time to learn everything else before you actually look at the answers. So giving yourself like literally a week, months, whatever, and you're always thinking about those questions in the back of your mind all the time. And that way, trust me, you're gonna wake up in the morning and have the answer. Like, it's weird how it works, but then you literally just wake up in the morning and your brain has been going and you just think of the answer. Or like you'll just be randomly out of your friends and you're like, oh my days, wait, that's the answer, that's what it is. Like, yeah, that's what you want when you're studying. Like, you want to have those moments where you realize the answer. Like, you don't want to always look at the answers straight away, but obviously looking at the answers straight away is really, really, really helpful because you need to actually know what is the right answer. We never think of the questions as part of the learning. We always think of the questions as the test, like that we're testing the knowledge and we're doing these questions to study for the test. But the actual act of doing these questions is actually the act of learning. So when you prolong how long you're getting the answers, you're literally thinking and learning. And also there's obviously things that I think you guys probably already know, like for example, if there's a question that you find really, really, really difficult and you got wrong, so okay, the way I do it, so when I'm first marking my answers, I don't look at the actual working out straight away. So I just look at the answer and see what I got right, what I got wrong. And then for anyone that I got wrong, I'm not looking at the working out yet. I'm gonna go back and see if I can like get it right without looking at the working. And then if I can't figure it out, then I look at the working. So that's another way that you're kind of like, basically the idea is that you're always wanting to be as independent as possible. That's basically it. And then also, you guys probably already do this, so keeping the questions, so the ones that you find really difficult, keep them, do a spaced repetition. That's the evidence from cognitive science. You guys already know spaced repetition. You want to leave a certain amount of days. So I have a traffic light system that I use on Notion that I'm also going to make a video about. But yeah, basically, if you find it really hard, then I think you want to retest yourself in like a week or something like that, a shorter amount of time. And yeah, you just keep a bank of all the questions that you found really difficult and just always reattempt them. But also with that, the thing is with memory, when you remember an answer, you're not really learning. So you want to kind of prolong it, drag it out as long as possible, where you kind of forget. And obviously, and the thing is, if you got it wrong, you're gonna forget quicker because you'd think that you would remember, but you actually don't. So the knowledge is more not really knowledge, it's more just memory. And then once you forget that memory, then you forget the knowledge. So yeah. And then obviously when you're marking the questions, you want to really look at exactly where you got it wrong. And even for the ones that you find easy, keep those questions and think about how you could solve it differently. So that's another way that you can learn, is just thinking about different ways that you can solve a question, because then you're applying your knowledge and doing all that stuff. That is it. It was actually a lot, so I don't know why I'm saying that's it, but yeah, that's it. So step 0, have a plan, obviously. Step 1, at the beginning of your study session, you want to do cold active recall. So think about the things that you learnt before, try to put the knowledge together, try to make a mind map. The most important, I think one of the best kind of techniques you can do is try to come up with questions yourself. And now you're starting the new topic, step 3, you want to look at the examples or look at the questions first, not looking at the answers, and try to figure out the questions and think about what you would do, and think about just literally throw everything you have at it, and then think about what probably isn't relevant and what is relevant. And then the reading, so that's when the reading starts basically, and you want to do active reading. So just asking yourself questions, trying to understand exactly why this is the case. Oh yeah, and then bring it back to your kind of the way that you were trying to figure it out, and that whole time you basically are not taking notes. So yeah. and then you want to take a note. So mind mapping is the best way, kind of figure out the hierarchy and the structure of the knowledge. And then the last part is the questions, obviously, and you want to kind of have like, I guess you could call it like a 2-stage process. So the first stage would be answering the topic questions and looking at the answers straight after, and then the second stage would be looking at the end of section questions that are mixed up and thinking about them. Just keep thinking about them every time until you get to the last topic of the chapter, and then at that point you should be able to answer all the questions. And it's basically the same process for physics. The only difference with physics is that physics is like its own subject, it's its own thing. Like maths is just logic, but physics is, you're actually studying something, so you can't always apply logic to it. That's the reason why I think it's easy to not easy, but I think it's good to try to independently figure out stuff in maths, because you're really just trying to understand the logic and trying to apply logic. But obviously with physics it's a bit different, so obviously that you just want to take that into account. So when the first thing you're doing is going to the questions, you want to look at each questions and see which one you can actually figure out and which one you would need more information for. And that in itself is like you learning and you kind of using your, kind of applying your knowledge and becoming smarter, or becoming smarter, because you are learning what in physical reality, or the physics of reality, what is logic and what is just physics. So yeah, that in itself is helping. And then obviously when you figure out what part is logic, you want to see if you can figure it out even without ever knowing, like without actually reading the section. So for example, this is something that I think would, if you could figure this out, you are actually a genius. I feel like you're on that level. So with like the, what is it, that all the different properties of particles. So for example, a neutron is 0 charge, a proton positive charge, +1 positive charge, all the different properties, the strangeness, the charge, the, what else is there, like the lepton number, yeah, I can't think of any more, but basically, yeah, if you could figure out the lepton number without ever even coming across it, or if you could figure out the quark, like the property of the quark, the actual numerical value of the quarks, like the charge of the quarks, without ever looking at it, that I think is, because the thing is, it is logical, like it actually is logical, but you have to think a lot. And they normally just tell you, but if you could actually just kind of deduce from, obviously from knowing maybe one, like knowing the charge of an electron, thinking about what would be the charge of the quarks, I think, yeah, that's a really good exercise if you don't know it already. But to be honest, I feel like I've even forgot, so maybe I could even try. But yeah, basically that's basically the only difference in physics, is just that you just want to ask yourself what is logic and what is actually just the physics, the properties of physics that you can't know, because unless you go out and actually do the experiment. So yeah, basically I feel like that's, yeah, if you actually do all of this, you will actually become a genius. Your level of thinking is just going to be like way higher, like, and you're going to be able to apply knowledge better, and you're just going to be more independent as a person. And I just think that is like going to be beneficial in any place. Like even if your goal is to like just get a job and you're not like trying to be like a deep pure mathematician, I think even just being able to think independently is gonna like take you far either way. And even like applying the maths, like logic and stuff like that, to other situations and stuff like that, is just, yeah, I think being smart is definitely gonna be beneficial in everyone's life. So yeah, basically